In this problem, I'm optimizing something to do with a box that's being manufactured. We're told here that the box has a square base and an open top. Since it has an open top, that means I don't have to worry about material for the top. We're told here that the box has to have a volume of 32,000 cubic centimeters. We're supposed to find the dimensions of the box that minimize the amount of the material used. So we have a set volume, and we want the material used for the sides of the box to be as small as possible. So to minimize that amount of the material, that's going to be the function I'm trying to minimize. We can call that Q, for that's the quantity we're minimizing. So I need to write an expression for Q, but I'm going to have to relate that to some other stuff in the problem. I think I'm going to need a picture so I can figure out what's going on here. So it has a square base and an open top. I can just draw sort of a rectangular box here. I'm making it so that the base, the bottom side, is roughly square here. All four sides along the bottom are going to be the same. In particular, I can call that X then, so that if I went around, all four sides would be X. This height of the box, though, that's a different quantity. It's not necessarily related to X, so I'm going to call that Y. And what I'm supposed to do then, minimize the amount of material used. To do that, I'm really then talking about the material for the bottom. That's going to be an area, and then the material, I've got four sides going around the box. Each of those has an area as well. And so the bottom, of course, is just square. All four sides are X. So the area of the bottom is going to be X squared. If I look at the sides, of course there are four sides going around the box, and each side is going to look like this. We can see that definitely here on the right. It's X on the bottom and Y going up, but that's repeated all the way around. It's a square on the bottom, so every X here is really one of these X's here, and then it's going up Y along each of those sides. And so my area for each side is XY, but there's four of them, so my total area is 4XY. So I'm supposed to be minimizing this quantity Q, which is going to be the total area for the box, which would be X squared plus 4XY. To minimize a quantity, I want to take its derivative and find any critical numbers and then test those. But I can't take the derivative here because I have two variables. I need to somehow go back and look here and say, is there any other way I can relate X and Y together? Well, what we can do is we know the volume. The volume of this rectangular prism, a prism, we've got a base here that's a square, and if I would cut across as I move up this prism, every cross section would be a square. That's what a prism is. And the volume of a prism then is just the area of the base times the height. So the area of the base is X squared, the height is Y. So what I know here, I know that the volume is X squared times Y, and that has to be 32,000. So that lets me solve for either X or Y. It's going to be a little bit easier probably solving for Y. So I'll just get that Y is 32,000 over X squared. And so this then lets me rewrite Q. Q is X squared plus 4X times Y but X squared times Y then will be X squared, 4X times Y will be 4X times this thing we've just found for Y, 32,000 over X squared. What I can do there then, I can clean this up a little bit. This X will cross out one of those X's, and then I'm going to write it using negative exponents. Well, this was not zero, that's my function Q. So my Q then is going to be X squared 4 times 32,000 is 128,000 and I'm going to get x to the negative 1 since it's in the denominator. And that's essentially my setup for the problem. And so now I'm trying to minimize this value q, which is x squared plus 128,000 x to the negative 1. And like I said earlier, to minimize a function, I want to find its critical numbers, so I need to take q prime. I bring the 2 down, I get 2x. I bring the negative down, I subtract 1. Negative 1 minus 1 gives me negative 2. And I can rewrite this a little bit. I can put that negative exponent back in the bottom. And now I can write this as a single fraction. And so when all the dust clears here, I get 2x cubed minus 128,000 all over x squared. And that's my q prime. Now, to find any critical numbers, I set q prime equal to 0, or I look where q prime is undefined. Since q prime here is a fraction, it's going to be equal to 0 when the numerator is 0, and it's going to be undefined when the denominator is 0. So we're going to get 2x cubed minus 128,000 equals 0. So 2x cubed equals 128,000. Divide by 2, x cubed equals 64,000. So then I'm going to get the cube root of 64,000, which is 40. 40 times 40 times 40 will be 64,000. To set q prime undefined, I would set the denominator equal to 0. That would lead to a solution of x equals 0, but that doesn't really make sense here because x is the length of the base of this prism, and also if I tried to solve for y, I would get 0 in the bottom. That would be undefined. So this, although it's a critical number, it doesn't lead to a solution for this problem. I've found a value for x. Now I have to find a value for y. I can do that back here, 32,000 over x squared. X is 40. So 32,000. 40 times 40 is 1,600. We could divide top and bottom by 100. So I get 320 over 16, which is 20. So we've got that x is 40 and y is 20. There is a question, do we really know that I have a minimum? For it to be a minimum, I would have to have this critical number of 40 would have to be at the bottom. So if I plugged in 39 or 41, I would expect to have values a little bit bigger than that. I can check that out by looking at q prime. If I look at q prime of 39, what do I get? Well, it would be 2 times 39 cubed minus 128,000 all over 39 squared. Well, if I plugged in 40, right, x equals 40 was my critical number. If I plugged 40 in up here, that would make this 0 in the top. So if I plug in something less than 40, this number is going to be less than it was before, and that's going to make this then less than 0 instead of greater than 0. So that's going to be a negative number, so it's going to be decreasing at 39. If I plug in 41, sort of the opposite happens. If I plugged in 40, this would be exactly 0. If I plug in 41, this becomes a little bit bigger. That makes the top positive, the bottom stays positive. So you can still do this on a calculator if you're not following what I'm doing here, but that ends up giving me a positive, which is increasing. And so since it is decreasing at 39, I have a horizontal tangent line at 40 and increasing at 41. It looks like that is a minimum at 40. And so the minimum amount of material occurs when the base is 40 centimeters by 40 centimeters and the height is 20 centimeters.